Hello, welcome back. In this segment, we will solve this equation x cubed minus 29x squared plus 35x plus 38 congruent to 0 mod 195. One of the techniques I'm going to employ is leveraging Chinese Remainder Theorem. 195, I can factor it as follows. 195 is same as 39 times 5, which is same as 3 times 5 times 13, right? If you multiply these, 3 times 5 is 15, 15 times 13 is 195. Since we are able to easily factor this number, we can solve it using smaller modulus. Instead of working with 195 modulus, we will work with 3, 5, 13. So if you know the prime factors, which is an interesting problem in itself, then you can easily solve this kind of equation by leveraging Chinese Remainder Theorem. Let me explain the approach now. So instead of solving this, we will be solving x cubed minus 29x squared plus 35x plus 38 is congruent to 0 mod 3 first, and then 5 and then 13. Okay, let's keep this one going now with 3 first. With 3, what can we say about x cubed? Fermat's little theorem is telling us x cubed is same as x in mod 3. Okay, that means this is nothing but x. What is 29 in mod 3 is minus 2 here, right? X squared. And 35 is same as, I'll keep 35 for a moment because 35 and the x can be added, right? 35x and x can be added. So that becomes 36x, which is same as 0 in mod 3. So we can cancel out these two. And 38 is same as 2, right? In mod 3. Okay, so you have this equation now, congruence now, which is minus 2x squared plus 2 is equal to 0, which means minus 2x squared is same as minus 2. That will give us x squared is congruent to 1 mod 3. So we need to solve x squared congruent to 1 mod 3 equation, which we can easily solve because mod 3 is simple. Mod 3 is, let's say, x is 0, 1, 2, right? What can we say about x squared? X squared is 0, 1, and 4. 4 is same as 1. The possible solutions for this particular congruence is either x is 1 mod 3 or x is congruent to 2 mod 3. Okay. Similarly, we continue this process for 5. In the case of 5, we need to, this is the case mod 3. This is mod 3, and we found out x can be either 1 mod 3 congruence or x is congruent to 2 mod 3. Okay, these are the two possible solutions for mod 3. For mod 5, we again have to simplify this original equation. It will become x cubed minus 4x squared, because in mod 5, 29 is same as 4. And 35 becomes 0 in mod 5. 38 becomes 3, right? Is congruent to 0 mod 5. Now, again, you can easily solve this with mod 5 because only 0 through 4, that means 5 possibilities you need to try to see where you get a 0. 0, 1, 2, 3, and 4. We will be computing x cubed, this expression, x cubed minus 4x squared plus 3 over here, which is when you put x equal to 0, you get 3. X equal to 1, you get 0. X is equal to 2. Turned out 2 cube is 8. 8 plus 3, 11. 11 plus 2 times 2, 4, 16. When you put x is equal to 2 here, you get 8, 16. So it's minus 8 plus 3, which is minus 5. Okay. So which is nothing but 0 in mod 5. And when you put x equal to 3, you get 4. You can try it yourself. And you put x equal to 4, you get 3. What do we see here are possible solutions? X is equal to either 1 mod 5 or x is equal to 2 mod 5. Okay, so this implies the possible solutions are x is congruent to 1 mod 5 or x is congruent to 2 mod 5. And now we need to do the same for mod 13. With 13, right, we can simplify this, becomes x cubed minus 3x square plus 9x plus 12 is congruent to 0 mod 13. X 0, 1, 2, all the way until 12 we need to compute, right? But then this expression that I will put it here, when x is 0, you get 12. When x is 1, you get 1 minus 3 is minus 2. This is 7 and 19, which means this is 6. And when x is 2, it becomes 0. You can try it yourself. So I stop here because I know x is equal to 2 is a solution for this congruence. So now we have an interesting situation. X is equal to 2 is giving us a 0 for mod 13. X is equal to 2 is giving us 0 for mod 5. And x is equal to 2 will also give the solution for this congruence. When we put x is equal to 2, we get 4. 4 is congruent to 1 mod 3. Yeah, so of course 2 is congruent to 2 mod 3 is true. So we have 3 equations. First equation, x is congruent to 2 mod 3. Second equation, x is congruent to from here. This is the first equation. This is the second equation. The third equation is again x is congruent to 2 mod 13 because of this. Okay, so this is the first, and the second is also 2 mod 5, and the third is 2 mod 13, which means we can now say x is congruent to 2 mod 13 times 5 times 3. That's essentially what Chinese Remainder Theorem said. You can just combine all of these. If clearly we can see 2 is a solution for all of these. 2 is congruent to 2 mod 3, 2 is congruent to 2 mod 5, 2 is congruent to 2 mod 13. That means we can say x is congruent to 2 mod of 3 times 5 times 13, which is nothing but the original problem, 195. So we found out that x is equal to 2 is a solution for this particular congruence. The beauty of this approach is that we are not solving x being 0, 1, 2, all the way to 194. Rather, we are solving a mod being 3, mod being 5, and mod being 13, which is much, much smaller than solving for large modulus. Though the fact you need to understand is that either you know the factors of the modulus, or you are able to detect the factors somehow. If you are able to detect the factors, maybe you are the ones who generated 195, then you know the factors. If you know the factors, this is an easy problem to solve. All right, thank you.